Hello, people of YouTube. Welcome to part 3 of extremely advanced, horrifying weapons or warfare of the future. In this video, I want to talk about a slightly different subject, than the previous two videos of this three-part series. In this video, I want to talk primarily about future nuclear technology, thermonuclear technology, subatomic technology, and that's where it gets very interesting. That kind of gets outside of the realm of current science. And I also want to talk about energy weapons, laser technology. And this video will likely be about 10 minutes long. I'm going to try to condense this massive amount of information I've obtained, and I'm going to try to condense it into 10 minutes. So, if you want to skip to the near end of the video, that's probably when I'll be talking about, energy weapons and all sorts of, magical, crazy tech that may exist in the future. And for those who are curious as to why I'm making this video, it's just because I want to give an idea. I want people to get an idea of what kind of weapons we might be seeing in the future and how to prepare, how to defend ourselves against such technology. Not that you really even could much at all, but, I can see it coming. Undoubtedly I can see something like this coming about not too long from now. So, first of all, I want to talk about, nuclear and thermonuclear technology. I think that it's getting smaller. I think that we've reached a point to where we can. I mean, I've seen it. There's something called Davy Crockett. I mean, if you want proof, that's all you need. That's all the proof you need. If you look up Davy Crockett, I believe that's what it was called. It was a very small little nuclear, rocket or whatever, or mortar. I think it was like a nuclear mortar, kind of. It was like I guess technically a nuclear mortar, but they launched it out of this like mortar rocket, whatever you call it, and and it the thing only created, I think, what was it, like a five or 10 kiloton blast or something. But I mean, despite its tiny size, I mean, it did some pretty decent damage, to the surrounding area. And I think that since that technology existed in the, what was it, the 50s, early 50s, I think that the small nuclear technology that we have today is probably the same size, but probably much more powerful. Not that little nuclear warheads are really even being built. Most of them are very large, because you know if we ever use nuclear weapons, they'll likely be launched long distance. So tiny ones don't really exist, but it goes to show that you could fit a big warhead on the tip of a ballistic missile, like the ones they have on submarines and in missile silos. And you could, I mean, with the technology we have now, you could fit a tiny little warhead or a really big one on a rocket, send it all the way around the world, and have it be 10,000, 100, a million times more powerful than the ones used in Hiroshima and Nagasaki. And that sounds crazy, but it's thanks to something called thermonuclear technology, which by the way has existed since the late 50s, believe it or not. The Russians and the Americans were developing hydrogen weapons, also known as thermonuclear weapons, back in the late 50s. And for those who don't know, nuclear weapons are basically regular nuclear weapons. Thermonuclear weapons are like super nuclear weapons. They're way more powerful because they work differently. They operate a bit differently. Just to be very vague, it involves fusion, the squeezing of particles, and it involves pretty much the same thing the sun does, how it causes nuclear fusion. That's what happens in thermonuclear weapons. And so my prediction is that in the next few decades we'll likely have not just way more powerful nuclear technology compared to what we have today, but it will massively exponentially advance in the next few decades, and we'll have thermonuclear weapons that I believe will be gigatons. Which, I mean, if you don't know, a gigaton is 1,000 megatons. Tsar Bomba, for those who don't know, look it up. Tsar Bomba was what, 55 megatons? Imagine a 55 gigaton, a weapon 1,000 times more powerful than Tsar Bomba. Imagine a 55 gigaton thermonuclear warhead. That would literally be well over, if I'm correct, a million. That would, I think, be 15, 30, 45, about 4 million, 3.5 or 4 million times more powerful than the weapon used in Hiroshima and Nagasaki. Can you imagine? Imagine like 3.5 million little boys, falling all at once. That's how powerful, these multi-gigaton weapons of the future could be. I mean, even Tsar Bomba, was very difficult to create. It was this extremely advanced three-stage, like 60 or 80,000 pound, nuke. I mean, it was massive, and it had to be. I think the aircraft that took off with it had to be modified quite a bit because the weapon was so huge. But the weapons we have today, we could create. It would have to be a weapon about the same size as Tsar Bomba, but nonetheless, we could still make one 1,000 times more powerful, thanks to new understandings in physics and chemistry and engineering, whatever it may be, all these new, all this new knowledge, all these new understandings of the inner world when it comes to atoms and everything. It's advanced quite a bit in the last few decades, and I believe that with quantum mechanics, theoretical physics, quantum physics, whatever you want to call it. I think that with the emergence of all these new physics, I think that we'll very likely have gigaton weapons in the next few decades. And to go even further than that, I think that we'll be able to create megaton weapons, megaton warheads, like that are a little smaller. They're a lot less speaking realistically, they would be a lot less powerful than Tsar Bomba, but way more powerful than the ones that were used in Hiroshima and Nagasaki. And they could fit. They would be, in reality, probably dozens of times more powerful than the ones used in Hiroshima and Nagasaki. Dozens of times more powerful than Little Boy. And yet they would be able to fit into a large backpack. And that's the kind of tech I'm talking about. Smaller, more powerful weapons. And on top of that, we'd have to make certain weapons bigger, but we can make certain future nuclear technology way, way, way more powerful. They wouldn't necessarily have to be super giant, but we could probably, I think, in the next few decades, create subatomic weapons, which involves the splitting of fundamental particles, which that's like theoretical, and most physicists would disagree with me saying that. They would say that it's not possible to split theoretical particles. But I mean, just speaking from my opinion, what I've learned, I believe that such technology is possible, and that subatomic weaponry will exist in the next few, probably centuries, most likely. But I think they'll come about. The first few will probably come about in around 100 years. That's my prediction. I mean, despite whatever physicists may say to, go against my claims, I think that, theoretical physics, quantum mechanics might disprove them. It might, might prove them wrong. I think I'm in the right here. I think that subatomic technology will exist in the future, and it will massively dwarf the capabilities of any of the weapons we have today, or any of the weapons we'll have in the next few years and decades. It'll dwarf all that. I'm talking like we'll have like teraton weapon technology in the next probably century or two, which is, by the way, that's like a million times. Well, to give a good example, that's like a billion times more powerful than the weapons used in Hiroshima and Nagasaki. Which, to convert that into like TNT, that's a teraton is 1,000,000,000,000,000,000 that's a trillion tons of TNT. That's how powerful a teraton weapon would be. Imagine like a trillion pounds. I think it would be in pounds or kilograms. Well, ton is, so I think that, yeah, it's like 1,000. Sorry, that's a trillion kilograms of TNT going off all at once. That's how powerful a teraton blast would be, and that's what I think we'll have in the next century or two. Now I want to discuss an even more powerful weapon technology, but one that's kind of it's not really that advanced at all. I mean, if anything, we're just scratching the surface of laser technology, photon energy, infrared laser technology, X-ray laser technology. All that stuff is very primitive. Like we're just now scratching the surface of such technology. But I think that in the next few decades, once humanity has developed the right kind of batteries, the right storage banks to like store power, and once we're able to build like fully like acceptable use fusion reactors, like fusion reactors that actually give out more energy than what we have to put in. I think once we have true fusion reactors, I think we'll be able to create laser weapons, and I mean like real ones, like the ones in Star Wars. But it's not gonna like fire off like cool colored beams of energy. It would probably be infrared energy, and the lasers that I think will exist in the future will be able to cut through stone, cut through glass, steel, cut through titanium, cut right through water. It'll be able to like go through anything super quickly. Because I think they'll be able to create microscopic lenses. I mean, they already do that now, but I think that are way more on point, way superior, to where they'll be able to focus a beam of light into a singular, like nearly infinite point, so small that they won't even need to use much energy to create like a very powerful infrared laser. And by the way, infrared lasers are like just the tip of the iceberg. There's so many different types of lasers. There's like microwave lasers, visible light lasers, like the ones you can see. Infrared are invisible, X-ray lasers, ultraviolet rays, lasers. There's all different types that can be created, but I think in the next few centuries, we'll have lasers that will be sort of like the ones that sort of come out of black holes, like quasar beams, which are pretty much just like super powerful, super hot, super fast moving lasers is pretty much what those quasar beams are. Like when light is seen coming out of a black hole, that's pretty much like a laser. And most of the stuff that comes out of a black hole, by the way, isn't visible. Most of it can't be seen, as far as I'm aware. But in the future, I think that we'll be able to create way more advanced lasers, and we'll be able to fire them using a lot more energy. Now, I think there's a limit to what kind of material we can use to where the lasers won't overheat and melt, because when you're using like what is it, petawatts, like there are some lasers that are tested that use petawatts of energy. And if you don't know, a petawatt of energy is, that's so much energy, and it's so hot that it could melt literally anything in the universe. I mean, it would be so hot that it can melt pretty much anything in an instant, like nothing at all. The highest the material with the highest heat or melting point is, I think, tungsten carbide, or pure carbon. Even that wouldn't last a second against like a petawatt laser. So, firing these lasers for very long won't work because it'll just melt the laser itself. But I think that, these weapons will be able to be fired, in very short durations. But they'll be able to be fired with so much energy that, basically it could go right through a little tank. These super powerful lasers will shoot a beam of energy right through a tank, right through an aircraft, right through a concrete barricade. It will be able to go literally like right through anything, melt anything, cut anything in half in like a millisecond. And so it'll kind of render most technologies, of the future pretty much, you know, uh, inferior. These laser technologies will shoot like one little beam for like 1 second, or I don't know, 100 milliseconds or whatever, and it'll literally cut right through an aircraft, cut the wings off an aircraft. Hit the shells in a tank and blow the tank up instantly. I mean, like no vehicle and no human will be safe against such high energy technology, unless maybe some material gets created that could deflect that kind of energy or resist that kind of heat. But I don't think there's anything like that that could be created ever, other than maybe like neutronium from a neutron star. But that's, I don't think humanity could create something like that. We'd have to like go mine it on a star, and that would be, I mean, there's too many things wrong with that to even make it possible. um but so yeah, that's the last thing I wanted to talk about for the series. But that would be the most horrifying thing, would be a terawatt or petawatt laser, being used in combat. I mean, even just one of those, even if just one of them was used, I mean, literally every time the thing would fire, it could just destroy anything in one hit, and nothing at all could withstand such energy. And perhaps even in the really far future, giant terawatt, petawatt, exawatt lasers could be built. They could literally like catch the atmosphere of a planet or moon on fire and incinerate the whole thing, the whole surface of a world. Or it could be used to blast a laser beam through the core of a planet or a moon. It could be used to like split a planet or moon in half. And I mean, I know that sounds crazy. To most people, they think, oh, that's just science fiction. That's not possible. But black holes, I mean, quasars, they literally emit like laser beams of so much energy, it could literally like melt the sun in like a nanosecond and turn the sun into a super. It could blow the sun up, in like a single second. These beams, these energy beams that come from black holes are like infinitely more powerful than anything the human race could create. And so, I mean, if you want to say that it's science fiction, you're wrong, because nature does it. Stars do it. Black holes do it. Galaxies, sort of in a way, do it. I mean, they release huge amounts of light and energy. But I mean, basically, there's a lot of stuff in nature out in space that does the same thing as we humans do, but on a much, much, much more massive scale. So when people talk about, oh, the thermonuclear weapons are the limit, oh, gigawatt lasers or petawatt lasers are the limit, we can't go beyond that. I mean, look at what nature does. If nature can do it, I'm pretty sure we'll mimic nature at some point, and we'll be able to create technology probably nearly as powerful as what nature can produce, if not even more powerful. Which I don't see that happening in like trillions of years, but who knows? Maybe I'll be proven wrong. But these are my predicted weapons of the future, technology of the future. that will far surpass anything that we have today. Now, these things may come in maybe only a few short years, thanks to quantum supremacy computers, super intelligent AI. They could think in ways far more brilliantly than us. Maybe they could create the technology, if we can't. So yeah, I think it could be possible in the next few years or decades. Seeing gigaton weapons, high energy, laser technology, nano machines, nano machines that could like disintegrate matter, they could, basically like attack a tank or something in like combat and like melt it or dismantle it in like seconds or minutes. I mean, I think that anything like that is possible in the future, and I think that we may even get to see something like that in our lifetime. Hopefully not, but let me know what you think about what I've said in this video in the comment section down below. And so yeah, let me know if there's any other topics you want me to discuss, and definitely comment if you can. So yeah, that's all.